All right, good afternoon. We're going to go ahead and start. Good afternoon, everybody, and welcome to today's webinar on building tall with mass timber, co-hosted by the George Mason Institute for a Sustainable Earth and the Center for Real Estate Entrepreneurship at the George Mason School of Business. We are here to learn more about manufactured mass timber, a building material still relatively new to the United States that allows buildings to be built faster, more sustainably, with a much smaller carbon footprint than steel or concrete, and with a natural look that is healthier for its space users. We will discuss two pioneering projects near our area. In Charlottesville, Virginia, the tallest mass timber building in the state is rising with the 8-story Apex Clean Energy Headquarters building. And in nearby Washington, D.C., a 2-story vertical expansion of ATM Street, a Class A office building, is the district's first mass timber commercial office project. But first, some introductions. My name is Eric Mary Bojek. I'm the director for the Center for Real Estate Entrepreneurship. For those of you that don't know us, the center is the university's platform for real estate development education, and its forum for important topics on the built environment. One of our interests is for better ways to build more efficiently, build more sustainably, and with a greater positive impact on space users and the community. We'd like to take this opportunity to thank the members of the Center's Advisory Board. These are some of the leading real estate organizations in the Metro DC area, which provide the guidance and financial support that enable us to deliver educational programs like the one we're having this evening. And now I'd like to turn over the screen to our host, to my co-host, Leah Nichols, the Executive Director of the Institute for a Sustainable Earth.
Thank you, Nick. Thank you. Hi, my name is Leah Nichols, as Eric just said, and I am delighted to welcome you all here today. So ISE was established in 2019 to help put Mason's research and scholarship into action for a just, prosperous, and sustainable world. We work to catalyze transdisciplinary communities of research and practice here at Mason by creating connections and building partnerships across disciplines and with communities, businesses, practitioners, and other stakeholders, so that together we can more effectively address the world's pressing sustainability challenges. I am delighted to be co-sponsoring this evening's seminar along with Eric and his center, and I would like to welcome you all. Before I introduce our distinguished speakers, thank you for the next slide, I would like to very briefly contextualize the importance of mass timber as a sustainability solution. Now, in 2015, the United Nations established a set of 17 high-priority sustainable development goals, which both provide a shared blueprint for achieving a peaceful and prosperous future for us all, and serve as an urgent call for action by all countries. I've highlighted 4 of these goals here. Number 9, build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. Number 11, make cities inclusive, safe, resilient, and sustainable. Number 12, ensure sustainable consumption and production patterns. And number 13, take urgent action to combat climate change and its impacts. Utilizing mass timber helps us make progress on all of these goals. I've also included a figure from the UN Environmental Programme's 2020 Global Status Report for Buildings and Construction. Now, as you can see, in 2019, buildings accounted for 35% of global energy use and 38% of global carbon emissions, with 10% of those global carbon emissions attributed to building construction alone. If sustainably grown and harvested, mass timber can be a greener replacement for steel and concrete and help decrease the industry's carbon footprint. Now, with that, let me introduce the speakers. Our first speaker will be Thomas Corrado, from a senior associate from Hickok Cole. He has been part of Hickok Cole Architects since graduating from Clemson University in 2006 with a Master's of Architecture. Thomas has worked on a variety of projects ranging from large-scale commercial interiors for the Department of Justice to projects that include the Center for Strategic and International Studies. Our second speaker will be Eric Ross, a partner at William McDonough and Partners. Eric Ross has more than 20 years of experience in the building design and construction industry. And after 4 years of service in the Army, he earned both a bachelor's and a master's degree in architecture at the Savannah College of Art and Design. Eric joined William McDonough and Partners in 2013 with a background in hospitality, commercial, and high-end residential projects. Joining Eric Ross will be his colleagues, Alistair Riley and Joseph Marchetti. If you have any questions during the presentation, please type them into the Q&A feature of the Zoom, and we'll answer them during the Q&A portion after the presentations. Now with that, I'm going to hand this over to Tom, and we'll get started. Thank you.
Great, thank you, Leah. Let me get my screen shared here. Okay. All right, so as Leah mentioned, my name is Thomas Corrado. I am a senior associate and senior project designer at Hickok Cole Architects. I've been with Hickok Cole for about 15 years, and I work primarily in commercial office and commercial workplace design. At Hickok Cole, we are a collective of about 90 architects, designers, graphic designers, interior designers, and we try to bill ourselves as a forward-focused practice that really has a vision to do work that matters. And we kind of define, and one of the ways we approach doing work that matters is through our research. And we have an internal research program. We call it an iLab program, and it really allows us to explore a number of different avenues and foster growth within the firm. But it also allows us to understand the current market drivers and how we can best service our clients through things like mass timber, net zero, construction, modular construction, those types of things. And that's been really successful. And it's, I started looking at the mass timber component about 5 years ago. And that was really advantageous when we were approached by Columbia Property Trust to look at their 80 M Street project. So 80 M Street is to try to just set up a little bit about the project. The goal was to design a vertical expansion for the existing 7-story occupied office building. And it was to create an exciting and differentiated product within the DC market. We achieved our goal, and we're currently in construction on about 100,000 square foot addition utilizing a full mass timber structure. And so we're adding 2 full stories to the building plus an occupied penthouse. The project itself is located in the Capitol Waterfront Navy Yard submarket of Washington, D.C. This neighborhood has seen kind of drastic change over the past 10 to 15 years. It's truly a mixed-use neighborhood. It's a good mixture of commercial office, housing, and entertainment, which is a bit unique to Washington, D.C. Typically, we're all office or residential, and so this is a really eclectic neighborhood, and there's a good vibrancy to it. And the existing building itself was actually constructed in 2000 and was one of the first, if not the first, kind of new development in that market in a long time. And so what has happened in the last kind of 10 to 15 years is that the neighborhood has really kind of grown up and around it. And this building really was due for an update. And the tenant on the top floor, which is the 7th floor, their lease was set to expire. And so it was the right time for Columbia to really pursue the addition and look into what was happening. And that vacancy on that 7th floor was really kind of paramount into allowing Columbia to investigate how to vertically expand this. Not having that tenant there with the remainder of the building being occupied really allowed us to explore how we were going to do this. So what you see here on the screen is some shots of the building as it existed prior to construction. You can see it's a 7-story structure. It's all concrete. It's a moment frame, and it's a 30 by 30 grid. And I'll get into some of the more specifics here in a few minutes. But let me jump to the next slide. So before we arrived at timber as a solution, we really needed to understand kind of the parameters that were driving the vertical expansion by itself. Vertical expansions are pretty common in Washington, D.C. There's something that we see quite a bit of, and they're typically and historically have been done with steel. And that's even an oddity in that DC is really a concrete town. Most of the construction that we do is primarily utilizing concrete. So, but steel has been a way of doing these vertical expansions in the past because it's a lightweight, it's lighter than concrete is. And so it offers a little bit, less stress on the existing structures. In this particular case, the existing structure and the zoning were kind of the two driving constraints and parameters of which we were looking at. We developed a number of scenarios to explore the potential of what we could do. And we quickly understood that our limiting factor here for this was going to be the existing structure. The zoning that we were working with would have actually allowed for 3 full concrete floors plus a penthouse, but the remediation to the structure, that it just wouldn't have been cost effective. There really would have been no way to make to make it profitable or to make it worthwhile. So it was interesting because it really became clear right away that we were probably going to be limited to the amount of density that we could do and that we could put on. And so we understood that really early on, that 2 full stories in a penthouse was probably the answer and where we're going to end up in order to not impact the existing structure too much. And part of that is because this is an occupied building. This building was going to stay occupied during construction. And so reducing the impact on the existing tenants was paramount for Columbia. And so we found ourselves in a position, which we rarely ever happens in DC, is where we actually had height and with which to design. We had upwards of 40 feet. And we typically are, we're trying to always cram as much density into our height limits that are pretty strict within the district. And so here we found ourselves, all of a sudden we had 40 feet and we were only really looking at putting 2 full building levels in, and then an occupied penthouse, which can sit above that zoning limit. And so steel out of the gate was kind of the obvious answer. But with our kind of background in timber, and now all of a sudden we had height, and we were dealing with a 30 by 30 grid, which was going to call for really deep timber members. So all of a sudden, though, we had the height to allow us to really explore timber. And with timber and steel being about equal in terms of their overall weight, timber really started to make sense because it offered Columbia a product at the end of the day that was going to set this building apart and bring this building up to and around the neighborhood that kind of had grown in and around it. So it was a differentiator within the market itself. So where we ended up kind of in our final section is we have 2 full timber levels that have a slab to slab height of 16 feet. And then we have an occupied penthouse up above that with about a 16-foot slab to slab height as well. One of the things I want to note here that's pretty interesting, but not in this particular illustration, is that the existing roof actually was not, it wasn't designed to handle an occupied live load for office use. So we needed to reinforce the roof. And so we looked at utilizing a carbon fiber, but that became too costly. But here we were again, and we found ourselves with this additional height. So we ended up actually abandoning the existing roof in place, and we created an interstitial layer of steel structure that kind of posted up off of the original concrete structure. And this was advantageous because it really allowed us to reset the grid and create a new structural deck. And it's proven to be really beneficial in construction, in that Davis Construction, who's building it, and they're the GC, they were really able to optimize the modularity and the kind of prefab nature of timber. And by really setting the grid, we didn't have to tie in to, we didn't have things showing up on site and all of a sudden we had to do tie-ins to the existing structure. We were able to set that structure in this interstitial layer. It also allowed us to reset the grid and go off grid in certain areas where we could transfer off of that, where we wanted to set the building back in places to, as you can see in this image, to kind of create terrace space in areas on the new floors where we thought that would be advantageous. Another thing that the kind of seeing here in the full building section, you can see those top floors and how much greater height they have over the what is a typical kind of office floor dimension in Washington, DC. And this was really nice in terms of the overall daylighting. We're able to get a lot more natural light deeper into the space just from the sake of having these taller floors. So when you combine that with a wood interior environment, it makes for a really, really spectacular office environment. And I'll show you some images a little later in the presentation here. You can start to see how that's starting to come to fruition here. With regards to code, this is kind of interesting how we actually were able to build timber above 85 feet. the current code under when we started this project, DC was under IBC 2012. And so that really, you could build mass timber under type 4 construction, but you're limited to 85 feet. And of course we knew that, coming in 2021 and the images that you see on the screen here was going to allow timber at a taller height. And so, using that knowledge, we had started meeting with DCRA during our research process, DCRA being our local code officials, and had been talking with them about how can we do timber? How can we do this? And they kept saying, well, bring us a real project. Let's find something tangible. Let's find something real, and then we can do that. And so we looked at these 2021 codes for guidance, even though they hadn't been issued. And we started to kind of think about and talk to DCRA about how we might fit our project within these three new types of type 4 construction that were going to be introduced. And so the interesting thing is that we really didn't fall in any one of those. We kind of fell in between, because we are really a 3-story timber structure going on top of a 7-story concrete structure. So we are, at the end of the day, what we really are looking to do here and how we are defining ourselves is as a type 4C building over top of a 1B of a 3-story type 4C building over top of a existing 7-story type 1B building. And so, at the end of the day, we're not 85 feet. We're really only, 40 feet. And we got DCRA to work with us here and to agree to see us in that light. And so we were able to develop a code modification in order to get us to build a high rise, because we're over 75 feet, timber structure within Washington, DC here. And so our code modification is essentially that. 85 timber structure over 85 feet, in our case up to 150 feet, which is the limit as determined by zoning. We also included a few life safety measures. We added a redundant fire pump, which is one of the stipulations that falls under the 4B construction type and under the 2021 IBC. So we did that. That was something we kind of, gave to DCRA as not necessarily a concession, but something we were looking to do to bolster the life safety aspect. And it's also because we were the type 4B allows you to go to a taller structure, but it also requires you to cover a large quantity of the timber. And we were not looking to do that. We wanted to have a fully exposed structure. So we were looking for ways to work with DCRA in order to have them allow us to keep that structure unencumbered. And one of the second things we did there is we upgraded our sprinkler system to regular duty instead of a normal light duty that we would be doing in a commercial construction. And so that was really beneficial. And so at the end of the day, we did this early on in the process too. This was something that we did right at the beginning of schematic design, because if we weren't able to develop and get this code modification, then the project really wasn't moving forward. So we, worked really closely with our partners at Arup, who are engineering partners, plus Davis Construction, plus ownership, and we got the package put together and went in DCRA, and we were able to get that going, and that really set us in motion. One of the other interesting things that we did discuss with them was that the building is freestanding on all 4 sides. It has access on all 4 sides for a fire truck. And that's something that you don't normally see in the district. Normally you're in an alley condition or having a neighboring building. But in this particular instance, we had access to all 4 sides. So I think, we were always looking for ways to make this more palatable, because again, we were the first. We were somebody, coming out of the gate, nobody really knew it. And so we were just trying to make people feel comfortable with what it is we were suggesting and what we were bringing to the table here. We did design, one of the other things we did is we designed the core as a steel structure. And this was really for 2 reasons. First, it was, we kept our egress stairs in a familiar construction type from a life safety standpoint. So there was a comfort level, again, with the code reviewers. They understood that, this was a steel structure. So moving from, if I'm in the timber structure and then in case of emergency, I'm getting into a stairwell that is a familiar construction type. And not only that, as I move and I traverse from the, what is the new 8th floor to the existing 7th floor, I'm going from steel, fireproof, 2-hour rated into, through a 3-hour, horizontal separation, and then down into my concrete stair of the existing building. So that was another way of just thinking about, a comfort level. The second thing was, that we used the steel as kind of a lateral structural system. At the time, timber wasn't allowed to take lateral per code. So we were looking for the steel to do that. The existing building itself is a moment frame. And so when we added the new floors to the structure, we needed to account for that new lateral loads that were going to be imposed on the building. And so there was actually no shear walls down to the existing building. So we created brace frames within the footprint of the existing core, and then tied those down into the moment frame as you move vertically down through the building. At the end of the day, one of the really interesting things was that the wood structure proved to be so light that we actually only ended up remediating and reinforcing 4 columns through the existing building. So we had really, really minor impacts to the existing building all the way down, and we did no upgrade. We didn't have to do any upgrades to the existing foundation. So we added 100,000 square feet onto this building with no upgrades to the foundations and really minimal remediation to the existing structure. So in terms of overall costs of an addition and adding square footage, it was a real benefit. And timber, I think, led us there. Now, could we have done this probably similar with steel? Probably, but the timber certainly has those same attributes. And at the end of the day, we feel like we're providing a better environment. In terms of the frozen, went too far. Sorry. In terms of the typical bay, as I had mentioned previously, the existing column grid for the building is a 30 by 30 grid, which is not necessarily the most optimal when it comes to timber. Timber performs really well in about a 20 by 20 grid. You can keep the member sizes down. They don't get so big, so that your 4x4s, you're not required to have 16 feet. But in this case, we had the height. We knew we were dealing with a 30 by 30. And so we were able to accommodate these large beam sizes here. So you see upwards, our primary girders are upwards of 36 inches deep, and then our secondary beams are 27 inches deep. And we were required to have secondary beams because our CLT panels are spanning that entire 30 feet. So we needed that reinforcement. The 30 by 30 grid has always been kind of one of our large impediments to timber within the district, because that's the market. That's what the market expects in terms of our column grids. But timber, as you can see here, is challenged in order to perform at the heights that we typically see, which are normally around our 11'6" range for a concrete structure. So the overall building, kind of the overall deck or assembly, it consists of the primary and secondary beams, and then we have a 5-ply CLT panel. And then we installed a 1-inch Acoustomat, which is therefore to get STC ratings from between the floor and to help with kind of footfall. And then we actually have a 3-inch reinforced concrete deck. And in this particular instance, we have the reinforced because we're actually using the concrete structure to take some of that lateral load, so back from the facades to the wind loads and so forth, taking that back into that steel core and transferring it down to the moment frame. So that's probably a little unique to this particular building and not typical of mass timber construction. I think most of the time you're going to do a concrete topping slab on top for noise and vibration and just overall mass, not necessarily from a structural reinforcing or lateral standpoint. Let's see. This is just an image. You can see in this image that even with those deep beam heights, we were really creating, this is obviously concept image, but we're really creating kind of great office space. And that a lot of that is due to those great ceiling heights that we're getting. So we were able to accommodate 3-inch beams, or, at the end of the day, it's a total of kind of 4 feet of a structural section when you go from the top of the concrete to the underside of the beams themselves. Another interesting thing is that because we are a high rise, we were required to have a 2-hour fire rated connection at all of the column to girder connections, as well as the secondary to girder connections. And at the time when we were doing this, there was really only one 2-hour connection on the market. And it was not, in our opinion, it wasn't something that was best suited for the project and the type of environment that we wanted to create. So we worked with Corrado, who is the CLT supplier and installer, and worked with them, and they developed a 2-hour connection for this project. And so they're steel connections. They're completely encased within the timber, which provides the fire protection for the steel itself. We were able to kind of do this, and because we had some other aspects of the job that allowed us to have some time. So we were able to accommodate the testing of these connections because we had to expand the elevators. We had to do the reinforcing of the structure itself. So that was advantageous because at the end of the day, we were able to get these approved. And that was really, really beneficial because so what you could see here is kind of that assembly. Each one of you have a post that goes from column to column. The CLT decks go across the primary and secondary beams, and then the secondary beams are kind of hung with these hangers into the primaries, and then everything is screwed together. Everything then is concealed within that within those connections themselves. Here is an image from the test. This is Astm E119. This was the test that was run. So you could see that there was a mock-up was constructed of the structural members, and then they were put into a furnace and they were lit on fire. This is under non-sprinklered condition. So not even what we would have out in the field. And here you can start to see evidence of the char layer. So you can see how the wood burns, but it only burns to a point. And there's kind of that sacrificial layer that offers the fire protection. And then you're still left with the amount of density and the dimensional aspect that's there for the structural integrity of the overall system. So at the end of the day, this was a success. We were able to get those 2-hour connections approved, and now Corrado actually has their connection for moving forward in any 2-hour rated mass timber projects that they may have moving forward. Kind of another view. This is a view from what will be our 8th floor that overlooks kind of the new tenant terrace space, and then views out towards the Anacostia River. Another interesting aspect to the design that we were working through was understanding the vibration. CLT vibrates. It's just inherent. All structure vibrates, but CLT vibrates more than steel and/or concrete. And we really needed to deal with the expectations of that within the marketplace. And so as you can see here, you expect the rope bridge to move, but you don't expect London Bridge to move at all. So how do we deal with the expectations, and how do we deal with vibration in the system, in the overall structural system? And there's 3 ways of kind of looking at it. You can use mass, stiffness, and indoor dampening. And Columbia property was very, they were concerned about bringing a timber building to the market that may get a bad reputation if it was deemed to have too much vibration within it. So we worked with Arup, and they actually have a technology. They actually have a technology here that it's called a motion platform, where they're able to replicate the vibration of concrete, steel, and timber structures. And then we were able to optimize the design to kind of meet whatever standard we wanted to meet. In this case, we designed the timber structure to kind of feel and act like a steel structure. And we feel like this was, this obviously, and to do this, I'm sorry, we added, density is what we ended up doing. We added a couple inches to each one of the girders and a couple inches to each one of the secondary beams. And that ultimately will take a lot of that some of the excess vibration out in order to get this to act and feel like a steel structure. And this was advantageous to Columbia, obviously, because it takes away some of their risk. but it was also, good in that this is the first commercial project in Washington, D.C., and think it's important that their market gets comfortable with this new structure and this new technology. And so, by doing that, they're covering themselves, but I think they're also delivering something that everybody will feel really good about at the end of the day. And I could say in practice, and having people come out to the building and visit the structure and everything, now it's been really well received in those regards. It's still under construction though. So let's and then in terms of timber itself, this is kind of, again, another concept image of an interior space. But the point here is that it affords tenants and end users the same opportunities than any other structural system affords. You can see here a kind of an internal communicating stair. This is achieved in the same manner as you would do in steel. You frame out the opening, and so there's no mystery. It's the same type of building structure that we're all used to. There are some different considerations. So it is important to kind of think through your designs and really, you dot your I's and cross your T's, so to speak. And the same can be said with kind of the exterior envelope systems. If you're thinking through, or you're using a curtain wall, then you need to design for a curtain wall, and you need to do that. And the structure can handle that. It can handle precast or brick. You just need to design to those things. So it's important to work with your partners and to think about those things up front. And then in our case, we were using for the majority is a standard curtain wall system that's going to be hung off of the edge of the timber itself. And so here you can kind of see we worked with Erie, who's the curtain wall manufacturer, and Katera to work through those connections. And at the end of the day, we're using the same curtain wall anchors that we would normally embed in a concrete structure, except in this particular instance, we're screwing them down into the timber itself, and using timber grade, commercial grade bolts. And so that suffices. That's the manner of doing it. And so having knowledgeable industry partners has been advantageous to us in that regard. And you can see here kind of those connections, and they're screwed at the slab edge. And then you can also see here in these images the reinforcement for the structure. So you have the slab edge with the kind of the bolts back through that will grab the concrete, and then the reinforcement. These all get tied in, and this will actually move that lateral force back into the steel core itself. And then the curtain wall, which is actually being hung now, will get hung on these anchors just like any other structure, that curtain wall structure. With regards to the construction itself, here's a couple photos. These are actually a couple weeks old at this point. There was approximately 70,000 square feet of timber itself that was, timber structure that was delivered on site. This all was erected by Katera. They produced the CLT panels themselves. Nordique out of Montreal was the supplier for the glue lam. But Katera did the install for all of the timber on this particular job. It was installed by a team of 7 that came from Katera's factory in Spokane. And they installed the full 2.5 levels of timber in 7.5 weeks. It was an on-time delivery, so the trucks would show up on site. They would all the CLT and gluams would be picked off the crane. They would work on one side, installing 3 guys working and setting beams and columns, and another 3 guys on the other side. As those were getting installed, the crane would move over and be picking CLT panels. So it moved very, very quickly, and took a crew of, like I said, seven individuals of which to install. So in terms of labor and time, I think there's a lot of savings. This project's a little different in that we did have steel and we have the reinforced concrete, so we have a few more trades that maybe you wouldn't normally see in a timber structure. But nonetheless, it was still very, very, very fast. And then you can see here, this is kind of what the inside of the space will start to feel like. So really gracious spaces. You can see those beams in this particular image. Those are, at the end of the day, we ended up, when we added density to the beams to get the vibration out, we ended up at 38 inches deep. And I would say to you here that those don't feel like they're 38 inches deep. That we do, because we have so much height in the overall structure. we're able to accommodate that and make for a really, really amazing interior space. And then lastly, some of the kind of ideas of carbon sequestration and the sustainable components to this for this particular project. And I think Leah was kind of hinting at some of this earlier. 39% of greenhouse gas emissions coming from buildings, with 11% of which, is the embodied carbon from the building products and construction. And I think mass timber holds a special place for us in order to kind of reduce that and contribute to these high performance and low carbon buildings. In fact, recent research suggests development of mass timber buildings constructed globally will double every 2 years between 2020 and 2034, which will allow North American building construction to reach carbon neutrality. So those are lofty goals, but they're there. ADM itself uses about 1,400 tons of mass timber, again, which is all manufactured, sourced, and installed by Katerra. That incorporates about 2,500 of cubic meters of timber, which the wood necessary to produce this timber and for this product could be grown in 8 minutes in North American forests. So just some kind of interesting things about thinking about the sustainable nature and the renewability of the resource itself. And in this particular instance, the project sequestered a large amount of carbon, which is equivalent to about driving around the globe 75 times. So just some kind of metrics and things that we're thinking about and trying to use the data and put it in a way that people understand. Thinking about how much a car would drive and how much time, that's how much carbon we're taking away and out of the environment by utilizing timber in this scenario. I'm going to stop my presentation there. Thank you so much for having myself and Hickok Cole. We are excited and privileged to be involved in this particular project, and we cannot wait for it to deliver. Its delivery will be at the end of this year, early quarter number 1 of 2022, sometime around then. And we're really excited. So thank you so much for having me, and I appreciate your time and look forward to any questions that you have.
Thank you, Tom. I'm going to turn it over to our presentation on the Apex building.
Where? To the first, yeah, do that one. Okay. Yeah. And then do the. Thank you, Eric. Thanks, Thomas. I'm Eric Ross, Director at William McDonough Partners.
Alice Riley, Design Partner.
And we also have, from the ownership development side, we have Joe Marchetti from Oregon Development.
How's everybody doing this evening?
Perfect.
Yeah.
Alistair's gonna kind of take the lead today, I think. We're gonna talk about why mass timber, what it meant for this project and this client, and what were the advantages we saw throughout the process as we've been constructing the project now for about 18 months.
Yeah.
Slated to be done by the end of the year.
So William McDonough Partners was set up by Bill McDonough in 1984. We've got some legacy projects we've done in the past for Ford River Rouge plant, the Gap 901 Cherry in California, which now Eric and I are both working on phase 2, which is now YouTube's headquarters, which is all mass timber. But we have a legacy of wood going back to 2002. We did Oberlin College, which was an all wood glue lamp structure and one of the first net zero buildings in the US. And we've also been working with Walmart on their new campus in Bentonville, Arkansas, which is 3.1 million square feet of mass timber. They're mainly 4 to 5 story buildings. So we're going to talk about Apex Plaza. As Tom said, the story around wood and the impact is a critical one. Apex came to us with the idea of how they could bring their workforce together in one place. Apex is a clean energy company that was a startup out of the Darden Business School at UVA back in the 90s. They've since grown. They were in 3, if not 4 different buildings. And their first desire was to get everybody into one office so they could collaborate. The next was to kind of prove what they're doing with the energy grid. Think about embodied carbon and offsetting that carbon within the building systems. We approach a project with somebody, Bill McDonough, like to talk about the 5 goods. To focus on good, clean energy, safe and healthy materials, clean water, circular economy, which we'll talk about a little bit with design for disassembly, and good lives. How can we create safe, healthy buildings with maximized daylight views and connection with nature? When we take those to Apex Plaza and some of their emissions, one of the first things was going for carbon-free energy. So how could we be 100% renewably powered on site, going to all electric, getting away from fossil fuels, and then again, operational energy as well. We've got battery backups for Apex. So a focus for them became clear from the start was, how can we think about climate-friendly materials? We focused on mass timber. We've been working with Nordic Structures and other timber suppliers in Europe. We've done 4 different projects, so going with mass timber made perfect sense.
And we've done, those have been residential, commercial, agricultural. We've kind of used mass timber across the board at this point, but definitely seeing the most activity in the commercial sector right now.
And in Europe, we've got to focus on circular economy. So thinking about design for next use and how can these buildings be put together, but also be disassembled. And part of that is this idea of material passport, that you maintain the integrity of the products and the materials so they can be reused. We're also thinking about how buildings are designed for next use, so how buildings can become housing in the future. And again, healthy, how can we be biophilic design, which is a connection to nature? And as both Leah and Tom talked about, just the idea of wood as the natural product, we're bringing then less, products to the table. So as I mentioned, Apex was a startup at UVA Darden School. They're spread across 3 different buildings downtown. So they really have this desire to stay downtown, to be connected to the downtown pedestrian mall. And they were able to do a partnership, which was ACAC Fitness Center had this vacant lot, which was surface parking. Horgan Development came on board, and then Red Light, which is a local development company as well. So Apex really wanted this idea to how do we keep our jobs downtown and have our people with easy access to the downtown community. And there's a free trolley service that takes you to Main Street and back to the university. So it's basically a gravel lot. When we started, we looked at maximizing the building envelope in allowable storage. We've got an apartment building next door, so we wanted to respect some of their views. We're accommodating both parking for the ACA Sports Club as well as the office. So we've got basically two levels of mixed use retail and then 2 levels of below grade parking. So we've got bicycle parking, electric car parking, kind of all on grade that's accessible to the group there. Then the next thing was how do we shape the building for the sun and solar access and views? And we've got long views to Monticello and the mountains to the south, views to downtown to the north. And then we've got a nice green podium for outdoor landscape area. As Tom mentioned in his, we've kind of then tried to think about optimizing the grid. 30 by 30, as you mentioned, gets into a stretch and we get quite large members. So here we're able to work with the parking grid and reduce that width to about, it's a little more than 20 foot.
20 feet, 8 1/4. And the advantage to 20 feet in one direction roughly is that the CLT is then allowed to double span across 2 bays.
Yeah.
And by doing so, it provides the primary lateral stability for the structure. And we're able to get rid of the purlins that would normally be there for bigger grid spacing to provide some pathways for service routing, MEP services.
Part of shaping the building too is to do these narrow bars so we get natural daylight into all the office space, and then optimizing the roof for solar integration. And as you mentioned, kind of a green roof terrace to the south. So that was kind of jump right into. We have basically 2 levels of mixed use. We actually do have an apartment in the building, ground floor retail, some ground floor or first floor mezzanine offices, parking below, and then basically with 7 stories of mass timber.
6 stories.
Sorry, 6 stories of mass timber, and then a occupiable roof terrace as well.
So, and you'll see it in the section that's coming up. So from a code perspective, we are a code compliant type 4 mass timber building on a multi-story concrete podium with a 3-hour horizontal separation. And so similar to Thomas and Hickok Cole, we worked with Arab and their fire protection experts on a code modification for the city of Charlottesville. They were very accommodating partners in that process, and they brought in some people on their side to kind of be their advocate and vet the ideas that we were proposing. So they had members from the code official from Martinsville, Virginia, who was on the IBC Tallwood Ad Hoc Council, the group that wrote the new code that Thomas showed.
Yeah.
And so we brought those pending or forthcoming code features for life safety and implemented them on the building so that the building officials would be comfortable with approving the project.
So at the end of the day, we ended up with a concrete podium, the 6 levels of wood, and we're actually 101 feet. So we're beyond what the typical code is, 85. And then we're able to do an occupiable terrace with a PV canopy. So we're generating energy as well as having an amenity. Apex has the upper 4 floors, and they've got a kind of 2-story atrium and balcony breakout. As I mentioned, we've got electric parking, and then we have battery backup systems.
Hold here for 1 second. And so this slide for us kind of represents the layering of the 5 goes to Alistair presented at the beginning. But Joe, if you're there, these features for the development team really became integral both for Apex, but also for the other tenants who are coming into the building. And Joe, if you want to just talk about the differentiating features they became for the marketplace.
Yeah, so, it's been what we found as we were, bringing this to market, knowing that Apex was going to take a certain portion of the building, but not all of it. The focus was obviously on leasing the rest of the space and how we could do that. And so, as we looked at the plans here, all of the open spaces, the rooftop amenity, the 3rd level green terrace, all added, really nice features that we found that tenants were looking for, in addition to the beautiful aesthetics of the CLT brought to the table. I'll say, we knew that it was going to be a pretty unique and beautiful interior look when we signed up for it, but I think it's exceeded everyone's expectations as we've gotten to the timber really being delivered, and we topped out the project last week. So that's been great. But all of the features that Alistair and Eric were mentioning, it really has been between the tall ceilings, the natural light, plethora of outdoor spaces, the beautiful wood aesthetics inside, it's really driven our leasing effort on the building. And so we sit there today, and we still have, I think, 7 months of construction left, but we're well over 85% leased at this point. So it's been a great outcome, and we think a lot of it has to do with just the way it was with the CLT product itself.
And I just add that we started pre-COVID, but we did about midway, I guess, a year ago, think about what difference. We already have a high efficiency mechanical system, and we do have operable windows, but we increased the filtration as well as integrated UV filters as well. But again, being focused on healthy materials, having daylight, access to nature, these are kind of all things that CDC's come out and saying, wouldn't that be great to have a workplace anyway? So we see there's kind of best practices beyond anyway.
100%. And with Joe's leadership and help also, we implemented some touch-free barrier improvements so people can come into the building now and have to touch points have been reduced as they come from their cars into the building and up to their workspace.
So this is construction a few months ago. Part of our ad hoc committee getting the code reviews, we did have to harden our cores. So we've got poured in place concrete cores. This is our concrete podium that separates below. But we're basically 1 hour for our wood. So we don't have the steel connection issues that Thomas mentioned, some of his. We're now, as Joe mentioned, topped out on wood, which we've got some shots.
So for reference, as Alistair mentioned, this is a month old timber topped out a week ago. And as he also mentioned, this has been going on through COVID for the past year. So we broke ground right before the pandemic hit. And the construction team, quickly implemented safety protocols and have maintained on schedule throughout that process. But what you see here, the fact that there's kind of 2 phases of the project is another indication of the brainstorming and the strategy they took. So Apex has a hard date, as Alistair said, they're in 4 buildings, but they have to be out by the end of the year.
Yeah.
And so it was imperative that the team come up with a way to build the project to deliver at that time. And so they phased construction to build the east side first, which is what you see, while we were still completing the west side. So as that west side was being completed, they've already started the east side to enclose the building. So it's been a real Herculean effort to stay on track. But, again, as a collaborative team, we were able to come up with these solutions to deliver the project on time.
These are some of the views of Apex. Again, they're the anchor tenant, so they've got the upper 4 floors. So predominantly exposed wood with the ceilings in that. We do have some acoustic kind of felt ceilings in some of the common areas and conferences. They do have a couple floor penetrations. And again, they have a double height atrium at the entryway. Part of the design featured this true north skylight. So it actually, at solar noon, we get a reflection or sunburst on the floor. I'll get some shots of that. Again, a big focus was renewable energy. So we wanted to think all of the places that we could integrate PVs. So we've got traditional roof mount PVs at the roof level. We have an upper PV canopy, which ends up with amenity space below, as well as a PV pergola on the 3rd floor terrace, as well as the outdoor green roof. So with that, we're able to be net energy positive for Apex floor, as well as provide, they've got battery backup for their power systems as well. This is the upper level roof terrace, the solar pergola. You want to talk about timber?
Yeah, so timber for us has really been integral over the last, I've been here since 2013, and Alistair said we've done 4 projects, but we really look at timber as an option for every project at this point. And a lot of that ties back into what Leah was showing early on with the UN Sustainability Development Goals and their target to reduce embodied carbon emissions by 30% by 2030 and ultimately, 0 by 2050. So we do see timber as a key partner in helping us achieve those goals. We also know that steel and concrete will play a role, and we are always investigating low carbon, embodied carbon strategies for those materials as well. But again, Apex was keenly interested in the idea of mass timber. And so for us, we've built a bank of knowledge over those 8 years regarding the topics you see here. So always staying abreast of the latest fire resistant studies and tests that are being conducted. Utilizing the product for its advantages. So it is a structural material, but it's also a finished material. So you're getting this beautiful aesthetic finished product from your building structure, which has advantages from both a biophilic perspective, bringing the nature inside for the workers, but also just not having to come back and clad all these structural elements with finishes. So timber, when sustainably produced and harvested, gives us a embodied carbon bank before we even start the project. So for this project, we're using black spruce, which is rapidly renewable. Nordic Structures in Montreal and Quebec have managed their own forests. They're a vertically integrated company managing their own forests. So they've been at the forefront of FSC practices for decades and have earned the newest FSC certification, which highlights their efforts to improve the lives of the indigenous people. So taking their sustainability ethos to the next level. But so we know we're getting a carbon bank before we even start. But that percolates again through it for new construction down through the concrete. So we've got lighter concrete elements, smaller foundations. And then ultimately we like to do the balance to see where we're truly starting from a structural standpoint. When targeting embodied carbon, you want to go after the structure because that's where the most mass is and thus the most embodied carbon. So the strategies for superstructure and substructure are critical to getting a building below that threshold to hit those overall embodied carbon targets. And so you can see here we're sequestering 2,000 metric tons of CO2 in our wood, which is great. And then balancing that out, we have a net carbon footprint for our structure before we start. And then again, as we think about the other systems, the enclosure, the cladding, we're always thinking about lowering the footprint of every piece that then attaches to the building beyond that. Yeah.
Want to talk about Nordic?
Yeah, so Nordic's been a great partner. Again, 4 projects with them, 2 an equestrian indoor riding arena, 80-foot clear span structure. They built those beams in one piece and shipped them from Montreal, installed it without a hitch. A stable, which was a CLT stable for the horses, and then HIT Collab, which some of you may be familiar with up in Fairfax. And now
Virginia's first mass timber.
And now Apex Plaza. So again, FSC Black Spruce, they're about 2 weeks away from being Cradle certified. So the first Cradle certified mass timber product in North America, bringing that healthy material ethos further. They've been great in pursuing that certification with us. Erection, again, they started phase 1 of that timber we saw in February, and again, just completed about a week ago. So significant schedule advantages. For reference, the concrete, digging the hole, pouring the concrete, all that site work, which some of the concrete is still being poured right now due to the phasing, has been going on for over a year. And they put the wood structure on top of that building in less than 3 months.
I think Joe could probably chime in, but one of the other ones is erection crews half the size. This is, a semi-urban site, so the site logistics, you've got less transport, less movement on site. How many trucks a day were we receiving?
Yeah, so the north side of the building was the laydown area. They were allowed to take about half of the road. 3 trucks a day coming from Quebec. So the erection crew, Chrisman, had 12 team members on site, handling the construction of the building, staying on track and on schedule.
Yeah, and I think to give a kind of a sense of like the difference in cross-laminated timber versus steel versus concrete. So, our structure here, similar structure of steel and concrete like we would typically do in a office building would be probably a 22-week construction process, and we basically use 2 to 2.5 times as much labor in order to get that structure erected. This cross-laminated timber project structure was took 16 weeks for the timber erection, and we had anywhere between 9 and 12 workers that were assembling it. So pretty significant labor savings, pretty significant time savings. If you were to then take that next step further and look at all concrete structure of the similar size, I mean, you're looking at basically twice as long to do that with probably 5 to 6 times the amount of workers. So while it hasn't been, much like any new technology, while it hasn't been, fully adopted yet, it's coming. And so there's a slight premium to the actual structural product. We found that, basically the speed and then, from a developer standpoint, that speed and the reduction in schedule, means, less carry, less, interest, et cetera. And so as we, look at that, plus the labor savings, time savings, it all kind of adds up. Basically makes the premium for the actual physical products, relatively moot. And so as, our zoning codes begin to, building codes begin to, allow for more, mass timber construction, under IBC standards, versus some of these hybrids that are currently going on, it will certainly compress those timelines even further, and I think allow for, economic viability to be very readily apparent to the marketplace.
And I would say one thing real quick so throughout the project, as with any project, cost was a major concern. And so we had some major heart-to-heart conversations about what design elements were most important to the ownership and the development team. And as we went through that, the timber always came back as kind of the non-negotiable, that we need to do everything we can do to hold on to that for the project. And so I say that only to say it was a team effort, the ownership, we needed that leadership, and we got it from both Joe and Apex as the main tenant. And it really helped to invigorate the team to get this done, because it was a challenge.
Well, and I'd add Nordic, we onboarded Nordic quite early. So another thing was optimizing that grid. As Thomas mentioned, he was restricted to 30 by 30 grid. Here we're able to go a bit narrower, which reduced the amount of purlins, which made, obviously less volume of wood, but also simpler erection time. So that was a critical piece as well. This is a shot of that upper atrium with our skylight slot going apart. It's part of the solar north piece. And Eric, I think that we can stop there. I know we're running out of time.
Yeah, that's good. Yeah.
Camera video.
I don't know.
All right. Thank you very much for presenting those two most interesting projects. You guys are certainly breaking a lot of ground for our area, and hopefully more to follow. So there's a couple of questions on the Q&A, so I'll just get to them. First question: the mass timber looks spectacular. However, even with a small event like a fire, it could possibly char the beauty of the exposed timber elements. Any thoughts on how a restoration would, what a restoration would entail if that happens, or what is the thought behind, I guess, repairing any damage to the mass timber?
Well, I could start just from a code standpoint. The char layer, as Thomas showed some of the sketches, has that built-in char layer, which is sacrificial. But the codes are written around life safety. So the first and foremost is to get people out of the building safely. So the building is still going to be standing. If it was a steel structure, we'd have bending, failed structure. So we'd be actually taking those apart, reinstalling them. In this case, the wood would have that sacrificial char layer, and it could potentially be retro.
It could, but I would also say we do everything we can to prevent that. So we do have sprinkler systems that are robust and are a higher class of protection to avoid that fire ever getting to that point that it would damage the material.
And again, we had upgraded the cores in that just to placate any of the life safety things. So in that case, we're more focused on codes and life safety than aesthetics and what you do with the wood after.
And at Hickok, we take the same exact approach. That's exactly right.
Okay. The construction sites seem so spotless. is this a photo op or is working with wood just so clean? Or I guess a reflection of the fact that there's a lot less waste as well. So maybe Tom, you could take that and then.
Yeah, sure, no problem. My experience with the construction site is that it is a lot cleaner. There is a lot less waste because I mean that goes to part of the prefab nature of the product itself. Things are arriving; they're not cutting or fabricating the on site, so you're reducing any of that potential waste. I will also say it's a lot quieter. It's amazing how quiet the site actually is, which is advantageous in our instance because it's an urban site and we have neighbors, and so we're also not impacting the community as much. But no, it does lead for a much kind of cleaner site. I mean, it's also the timber is beautiful, so when you're standing in that, it's a lot different than the concrete. You also don't have in like a concrete structure any of the post shores or any of those things that you would have. So your floors are delivered a lot sooner and they're ready to get other trades in. And so there's not all that clutter that's associated with some of the other structural materials.
And it's coming, the prefabricated nature of it. So it's like literally it's all being dropped into place like right then. And it's a finished product, right? So, if you look at some of the pictures that Eric and Alistair showed you, the floors are unfinished because you're going to be, topping those with a sound matting and then, layer of gypsum to help with the sound attenuation, vibration, etc. But all the columns, all of the ceilings, I mean, those are finished products, and so it's meant to be just that. So what you see, you're going to get in the final building. So, but just the ease of the erection process is just that it doesn't lead to less waste. So it's pretty cool.
And I'd add part of that prefabrication, all the mechanical changes, all of that is, we're working with a Revit model, BIM model to integrate all of those cuts. So all of that is off-site, done in the factory.
Does the wood need to be sealed so it does not absorb a large amount of moisture?
It's delivered to the site with a factory sealer on it. We're not exposing the timber for the long term, but it does come with a factory sealer. And in some cases, we're coming in with a coating on it. We would certainly treat it differently, I think, if we were going to actually leave it exposed. Okay. And then for the upper roof, there's a temporary roof system put on to protect it during construction.
This is maybe more for Joe as well. Can you share a little bit about the economics of timber? I think you alluded to it a little bit, compared to concrete and steel.
Sure.
How does it come in as a project economically?
Yeah, obviously construction costs vary market by market, right? But given the, what I was told you a year ago, before we started seeing material increases across the board, there was a modest premium to the physical product, to the tune of $5 to $15 a foot, depending on where you're getting it and who was making it, and what the exact specifications of your project were. But like I said, I think that the time savings and the interest savings kind of nets all that out. And in addition to the labor costs, it basically makes it so that premium that you're actually paying for the structural product itself is effectively, very comparable to traditional steel building. What I would tell you today is that, the couple of projects that we're actively working on, we are looking at CLT options, both for multifamily and for office buildings, that are, because we think just given what's going on with steel and joist and deck and those sort of pricing that, we would expect that, or actually that premium may have, totally evaporated. And so then CLT actually may end up being more cost effective. We haven't proven that yet, but it's something that we're, looking into at the moment pretty heavily.
Leah, did you have okay, I'll just go to the next question then. This may be related to what you just discussed, Joe. How is the rising cost of timber or I guess lumber, not timber, rising costs of lumber affected your outlook for the future of more mass timber developments?
So I think that, and I'd let some other folks chime in on that as well, but it's a little different product because this is a highly engineered product, and who we have procured our CLT from, and the glulam was all coming from Nordic Structures, and they're, as Eric and Alistair mentioned, they're fully integrated. They do not sell their lumber, they don't sell their timber on the market, and so they're basically have been insulated from the pricing pressures that we've seen on the residential multifamily side, as it relates to true stick construction. And so I would tell you that probably more of the cost that's baked into this is more to do with the engineering that goes behind it and the manufacturing process versus the actual raw material.
So this is a completely different supply chain than residential lumber. In effect, it's a different pricing, different sourcing, different supply chain altogether.
Well, I think as Joe mentioned, Nordic is unique that they literally own the forest, and they've got an FSC rating on that, so they are vertically integrated and able to deliver. They competed on the California YouTube project with two other vendors out of British Columbia, and I think they were able to win on those points, and also the fact that they were going for this cradle-to-cradle certification and FSC was a critical piece. On the other hand, Walmart, who's again doing about 3 million square feet, they've actually invested with Structure-Lam, another company out of British Columbia, and starting a new plant in Northwest Arkansas. So they're going to eventually harvest, timber out of Arkansas and actually feed into Texas, other markets. So Walmart is a purchaser first and foremost for their campus, but the idea of long-term. And I think from the Walmart thing, the sustainability is baked in. Again, they love the idea of, they're working in warehouses now. We build these simple wood structures, no extra finishes, no premium on coming to do acoustic rating, things like that. So they looked at it as kind of a no-brainer, and now it's been 2.5 years, but really put that investment in Structure-Lam to feed, the rest of North America. So right now it's coming from, Pacific Northwest, or it's coming out of northern Quebec.
And if you look at the section of a glulam member, it's made up of really small pieces of wood that are glued together. It's not the same as a 2x4. So the trees they're taking are of a different caliber, a different growth rate. So they're looking for a very specific product that doesn't fall into a stud, as Joe said, a stick market.
Yeah, I would say that's a good point, because the optimization then through the manufacturing process, like, it's different. They can use any offcuts or different sizes of these pieces of lumber that integrate into the panels or the members, so they're not beholden to kind of what you would normally see in terms of residential construction, in terms of the sizing of dimensional lumber. So,
and that harkens back to the clean site, because they're optimized at the factory level. It's less waste, less use, and using material that might have been thrown aside because it's not a full size timber. It's not what we would think of old growth or large size timber.
And the struggle is more about supply and demand right now. So these projects are very popular, as Joe said. They're looking at them. We're looking at them. Thomas's team is looking at them. So production windows with any manufacturer are the key. So it's critical that you lock in with your supplier as soon as possible before drawings go out. I mean, we brought Nordic in at DD to lock in that production window, and it becomes a fixed, hard date that the team has to work towards. But they're all producing. Nordic, I think, just opened a new plant that doubles their capacity, but and then Alistair said there's a new plant coming in Arkansas. We've seen interest from people that want to bring production.
Thomas working with Katera, which is again trying to get vertically integrated into it. So.
And I would add that those relationships have been paramount in our success with timber, like getting to know Nordic and getting to know Katera and Structure-Lam and all these people, and getting them as partners. That's only helped our success for sure.
Maybe as a sort of a concluding question, what is the hurdle or bottleneck, do you think, towards greater adoption of this type of technology or construction? And what can we do to sort of spread the word or get more developers to consider using mass timber as a building material for their projects?
So it's Tom, and I'll be quick. The codes that Thomas highlighted are coming and will help a lot. That opens up the potential market for these buildings to other avenues, multifamily, high-rise, office, et cetera, et cetera. Developers and builders like Oregon who have experience and can speak to real-world empirical data about cost, time, advantage, et cetera, erection. The more we do this, the more the hurdles will fall away.
And we're seeing demand, sorry, on the client side, as Leah mentioned, that Walmart's looking at the UN sustainability goals. Google is focused on reducing their carbon impact in the real estate portfolio by 50%. With our new building, we're in the 60% based on the switching to mass timber, the renewable story, and then also looking at embodied carbon and the building materials, being the facade, et cetera. So I think the corporate world is moving in that direction, and to see Walmart, leading that direction, it's a big thing. So others are taking notice as well.
Yeah, and I would add that, in addition to corporate sustainability goals, just from just a general market standpoint, it's just it's seeing the products, right? I mean, this has all been theory for a very long time. I mean, I think actually, the first time I talked about CLT, it might have actually been with Tom up in the Hickok Hall office, but a couple 4 or 5 years ago. So it's just actually doing projects and then bringing them to other people to see. I mean, I can tell you just the general outpouring that we've seen from, not just in, the Charlottesville development community, but the Richmond development community, folks from DC asking to come down and tour our building. We're getting a lot of interest across the board. People want to see it. They want to understand how we did it. They want to understand all the costs behind it, and how it's viable. And I think as you see more success stories, then you're going to see more of it. And obviously, then there's a production side of this that then, as we talked about a little bit, it needs to pick up. And as demand increases, obviously, hopefully then the supply of it will also do the same, and we'll see more of these manufacturers spread throughout the United States, because the product has been readily available in Canada and Europe for a long time, decades. So it's really just adoption here, and I think once people see it, then it will start to become more commonplace.
Final word, Tom?
No, I agree with everything they said. I think it all comes down to education and familiarity. And the more we have projects like Apex and like ADM that we can bring our clients and people to in general, the more success we're going to have. So I think everybody hit it on the head.
Okay, well, we certainly look forward to, both of these buildings are finishing up at the end of the year. So we're certainly looking forward to hopefully seeing them in the flesh. And for sure, when it comes to the education portion, George Mason is we've always been interested in the topic, and we will be part of the effort to educate the industry and people around this technology and other technologies that will provide more sustainable buildings. So I think with that, we'll just turn it over to Leah to sort of conclude our event this evening. And thank you very much.
Thank you all for your presentations. That was fantastic. Really interesting work, and glad to see it starting to make an entry point into the US. And thank all of the participants who are online listening for coming as well. So with that, I'll just wish you all well and have a good night.
All right. Thank you very much, everybody.
Thank you.
Thank you.
Good night.
Bye.